The last time I let the cat out of the bag, so to speak, and told you guys what I was working on during the intro. This time, not the case. You're going to have to watch this one to figure this one out, because I'm not going to let the cat out of the bag and give you any spoilers. But I will say that this was sent in from a viewer to me to have me do a bit of work on it. So let's check out this mystery item. Today I received a relatively large box at my P.O. box. I don't even know what this is, so let's figure it out together and see what I was sent. Well, it's packed well enough. What goodies did I get today to fix? This is salvage electronics, therefore it's something that's coming to be repaired. Let's take a look and see what I got. Wonderful. Styro chips all over the place. It's actually quite heavy. What is this thing? Thing weighs a ton. Well, for starters, it has a power cord on it. Let's open this thing up and see what it is that I got. Got a nice big heavy duty power cord on it. As they say, it weighs a ton. This thing costs a small fortune, I'm sure, to ship. But what did we get? Saving the best for last. I know what this is, by the way, but you guys don't. So this is an isolation transformer, but this isolation transformer is not in its current form suited for working on electronics, and I will show you the reason why. The reason why this isolation oh, wonderful. Cord strain release popping apart. The reason this isolation transformer is not suitable for service in its current form is because there is a reference to ground to the secondary. If I put my meter on the ground prong, you will see that I have continuity. And that's because the ground terminal is connected to the secondary transformer, which is not acceptable. Yes, it provides isolation between, right? It provides isolation between the live and neutral, right? Isolation there, but the problem is it's the ground. And to make one of these things safe, we need to isolate the ground from the secondary. And this was sent to me by one of my viewers who I've sold him a couple of calibration tapes in the past, and he asked me, he said, if I get this isolation transformer, I send it to you, can you make it safe to use? I said, sure, we'll make it safe. So we're going to isolate this thing, and I'll show you guys how to go about doing it. So if you get your hands on one of these units, it's very easy to isolate this. We're basically just going to isolate the ground from the secondary side of the transformer. Anyway, it's pretty straightforward to do this. We're going to take the top off it. We're going to remove the screws and lift the top off. Okay, unit apart. Pull the top cover off. One of these ways this cover will come off this thing. Okay. So all this is basically it's a 1-to-1 ratio transformer. My isolation transformer looks just like that, but it does have a cover over it, but it's not in a box like this. What we need to do is we need to isolate the grounds from everything on this that could cause you to get a shock. So we need to isolate the secondary, which is these windings over here, right? There's your secondary. There's the two windings for the secondary. This is a ground wire that's actually grounded to the secondary, we need to remove this ground wire here, and we need to remove the ground going to the plug and the ground going to the receptacle here. So a couple ways to do it. We can remove the actual plug. That's probably the easiest way. We'll just take the plug out. Maybe that's not the easiest way, but now there's a reason I have to remove the grounding from the actual chassis here as well, and that's only because otherwise you could still have ground. The actual plug itself is grounded through the tabs, which would be grounded to the case. So we want this whole thing isolated. So I'm going to remove the ground wire here. Don't even need to put that screw back in. Now say this is still going to be connected by metal screws to here. So these tabs here and the ground prong here is still going to be tied to the metal case. So we have to isolate that from the rest of it. You can see what they've done here. They've got the green ground wire. One went to the ground plug on oh, that was on, I didn't have to take the screw out. It was on a hook. It didn't look like that from the angle I was at. The other green wire, of course, goes to the neutral connection. So we can just remove this one. Okay, that's got the neutral isolated. There's another wire that goes down into the core of the transformer. Let's just see whether it's just connected to the core or whether it's actually still connected to the ground plug or the ground or one of the terminals. So that looks like that one's probably just grounding. That's just grounding the core of the transformer. But we don't want that either because we want everything completely isolated. Right now, by just removing the green wire that went to the neutral and the green wire that went to here, I've now isolated the actual plug from the supply. But as you can see, if I connect the plug, as soon as I connect it back up to here, I've kind of defeated the purpose. So I actually have to remove all the ground wires. We'll just do that right down here. We'll just take all the ground wires off as they're no longer needed. Now I know people are going to say, oh, you're defeating all the safety. I'm not defeating the safety. Okay, this type of transformer, this was designed, this is what they call a medical grade isolation transformer. And what it does is it isolates the equipment from the line by means of a transformer at an effect of trying to prevent power surges, because the transformer will saturate and absorb a lot of power surges, but they still pass the earth through. And for a service bench, you don't want the earth at all connected to this plug. You want both sides to be completely isolated. And the reason you want both sides completely isolated, I'm just going to cut this one here off too, as it's not needed, and we'll just put some heat shrink on there. The reason you want your plug totally 100% isolated from ground fault is because how an isolation transformer protects the service person who's servicing, and these are used by service people to service electronic equipment. How it protects the servicer is if the servicer accidentally makes contact with with a line signal, like a line voltage, the short prong basically on a conventional, or black wire on a conventional outlet, and they are grounded, the current will flow from the line through the person to ground and can electrocute them. And the same thing would happen with the ground wire attached to the ground prong on here, and by means of the neutral wire, which was also grounded. This basically defeats the purpose of having the transformer to begin with. If you're passing your ground through from the line side to your load, you're defeating the reason that you're putting the transformer in, which is to provide the user with safety, isolating them from accidental contact with mains voltage. The whole idea behind an isolation transformer is that both of these terminals float with respect to ground. So if I were to short between ground and this pin, nothing would happen. If I were to short between ground and this pin, nothing would happen. Why? Because the transformer secondary allows it to float. If I were to ground out the hot pin, guess what happens to the other pin? It becomes the live pin. If I ground out this side, the neutral side, the hot pin becomes hot. If neither one of them is grounded, they will both operate with respect to ground, but isolated at about half the line voltage. But isolated, you can ground either side and you'll have no complete circuit. So I could touch the hot wire and touch ground. And as long as I wasn't touching the return or the neutral at the same time, I'm isolated. That's how an isolation transformer works. But it only works if the secondary winding is completely isolated from all forms of ground. And that includes through the tabs here, which is why it's so important to disconnect the green ground wire where it goes into the base and grounds this chassis. It all has to be disconnected. If this was mounted in a plastic box, if the outlet was mounted and isolated from the metal chassis on this, I could leave the ground screw and ground wire connected to the metal chassis, and that would keep this at ground potential and never allow this to float if, say, one of the wires here were to break off and touch the one of the hot wires were to break off and touch the chassis. Now with the ground wire disconnected, yes, if one of these wires were to break off, the hot wire say, and touch the chassis, this could be electrified. That's always, the slightest of risks. The chances of that happening are slim to none. On the other hand, the chances of when you're working on a hot chassis, television or radio, the chances of you accidentally touching something that's energized when your other hand is touching something that's ground are a lot greater. So this protects the servicer. And every service bench, anybody who's working on any electronics really needs to, for their own safety, have one of these. One, it'll protect you, and two, it'll protect your test equipment, like your scope. If your scope is plugged into here, now your scope is floating. So the ground lead on your scope will float. Now, a lot of times servicers will want to have their scope grounded for obvious reasons. Not so much for safety, but so that there's a reference to ground. So if you plug your scope into your regular standard grounded outlet, this is at ground potential. And this is where a lot of guys get into trouble. Their scope is plugged in and their ground probe accidentally hits something that's hot, that's connected to line, and then they have major sparks. This will prevent this. My scope is plugged into power. This is at ground potential. I could touch this to the hot side and nothing would happen. I could touch it to the ground side, nothing, or the neutral side, nothing would happen, because the entire potential will reverse. If I took this and connected it up to the hot ground, all of a sudden, or to the hot supply, all of a sudden that becomes ground. And everything else shifts. The neutral side would become the hot side if you were to pull it to ground. Anyway, that's the way it is. But yeah, servicing these things servicing these units, making them safe is relatively simple. Just cut the green wires off, cut all the green wires off on the inside. I'm going to fix that strain relief that's popped apart. And we're going to put some heat shrink compound on here, and then we'll check this thing all out and test it out and make sure everything is good. And we'll check it for isolation. Well, it's safe now. I'm going to reattach the plug. And then this unit will be ready to send back. After struggling with the strainer relief for a couple minutes, got the strainer relief back in. We're just going to put some heat shrink tubing onto these two ground wires here just to make sure that they never can touch anything and defeat the purpose of removing them in the first place. Okay, now we can test the unit for any continuity between any of the outlets. Switch is on, obviously. We should see infinite resistance between all of these. I'm just in diode test mode now. As you can see, no continuity between anything, which is how it's supposed to be. If I check continuity between the pins here, you'll see that there is no continuity between the power plug. There will be through the primary, which is normal, and there will be on the secondary here, which is normal, right? But no continuity between the ground and any of the outlets. This unit here is 100% totally isolated. If I plug in power, I'm going to plug this into my non-isolated power bar. For an AC volt measurement, the power is turned on. As you can see, the light is lighting up in the front, so we have power, and we have 124 volts, which is about right. Turn it off, we have 0. Okay, thing to remember is I can touch either one of these terminals and not get a shock, right? Even if I'm touching ground, I'm not going to get a shock. If I put my finger down between the two of them, yes, I'm going to get a shock for sure. But if I touch either one of them, either the hot side or the neutral side to ground, because there is no ground, even if I'm touching something else like this lamp arm, which is grounded, okay, I can take my meter and I can measure to ground. Let's just go and measure to an earth ground. I'll use my scope probe because my scope is grounded. To prove that my scope is grounded, I'm going to take this side and I'm going to plug this into the ground prong, the ground hole on my power bar. As you can see, my scope is grounded. Okay, now we go back. If I put this on voltage mode, AC volts, if I take the same probe, I'm just using the black probe in this case, and I plug it into the hot side, you will see 121 volts. Okay, I'm just plugging this in to a little short extension cord here, but this is plugged directly in. There's the line side, and here's the neutral side. There's the line side. Okay, now we plug the isolation transformer back in, and we do the same here now. Okay, got exactly half the voltage because it's floating. You'll have 64 volts on one side and 64, well, 21 or so. It's grounded though. The thing is, I can touch this, and you watch, just my skin resistance will take this down, right? There's no current flowing through here. If I ground this wire out and we find a source for ground, you'll see that there's no sparks or anything because the transformer is going to isolate it. So I'm going to get a ground wire here, and we will ground. I think it's grounded here. See? No shorts. So just took a wire here, right? We're measuring the floating voltage, but it'll go to ground. Right? Same as if I do the other side here, it'll go to ground. But that's what you do. We've got our 120 volts across the plug, but with reference to ground either side. Ground anything, as I say, my scope probe here is grounded, it'll just take it right down to 0. So either side, if I ground either one of these, remember my scope probe is grounded. Okay, 0, 0, right? That's why you have an isolation transformer, so that if you accidentally make contact and your hand is grounded with the hot side, it's going to pull it to ground potential through your body, but it's isolated. If I did this to the input, we'd have major sparks. So that is how you modify one of these triplet isolation transformer, which really should not be called an isolation transformer, because they're not isolated from ground. But the vast majority of these things that you are going to find for sale are of this design. All you have to remember is that if you measure between the ground prong, ground pin, there should be no resistance on anything. Should be infinite resistance on every connection. So if I go to ohms mode here, instead of diode test, ohms mode, it'll show resistance if I touch it with my fingers. 6 mega ohms is my skin resistance. Okay. Overload. Overload. Right? Infinite resistance. That is what you want to see. If you see resistance between the ground pin and any of them, then you are not running a true isolation transformer. And the same goes for any of them. Every single pin should be open completely, because there is no physical connection between any of these. The only time you should see any resistance is between on the primary and across the secondary. That's the only time you'll see any type of resistance. That's it. Thanks for watching. Now I gotta box this back up and collect some money from the guy that owns it, enough to get it sent back to him. And this thing weighs about 20 pounds. Nice transformer. Very nice transformer. Ah, made in Taiwan. Oh well, it's still a nice transformer. Mine's made in Canada. Mine's better. Thanks for watching.